Alright, I got a pretty simple little problem here that I set up. I pretty much just done it in small, simple steps to make it easier to understand. Um, since that's pretty much how I like to do everything anyway. So the first thing that we have is we know that the capacitor has plates that are measured zero point 0.1 meters by zero point 0.2 meters, and the separation is 0.000. I guess I could have wrote that in millimeters, but I just skipped that step to keep it easier. So the first thing we know is that the capacitance is equal to Q over delta V, which since we know the formula for, we can pretty much plug in this right here in place of the delta V. So when you do that, your Q's are going to cancel out. So that's why you don't have any Q's in this second formula here. And let's see, you end up with E naught times the area of the plate and then over the separation of the two plates. So pretty much here I'm just showing the two values that we're going to plug in here. So I got the area is going to equal 0.02 meters, and looks like I forgot the square there, but oh well. And then the separation is 0.0003 meters, and E naught is 8.8 e to the negative 12, or times 10 to the negative 12. So whenever we calculate it, we get 5.87 times 10 to the negative 10th farads, and I believe my units are right. My uh, meters on the bottom and meters squared on the top. Let's see, cancel that out. Farads, meters squared. I know that farads are, let's see, farads per meter squared, I think. Okay, I had to stop and think about that one for a second, but yeah, everything cancels out. All the meters cancel out. You got two on the bottom, two on the top, pretty much. So you're left with just the farads, and then from there, we take this. We're going to take this formula and solve for Q, because the next thing I'm going to do is solve for Q. So I want to know the charge on one of the plates. And when you solve for Q, you get Q equals C times delta V, and of course we have our C value, our capacitance value, and we know that delta V, it's going to be just the EMF here, 1.5 volts, and we're left with 8.8 times uh, e to the negative 10 farads times volts, which is of course coulombs.